I'm Alan Fenn. I'm senior staff in the RF Technology Group at MIT Lincoln Laboratory, and I would like to welcome you to the RF Systems Test Facility. We do rapid prototyping here. We build antenna sensors that can be integrated with aircraft here at the laboratory. So it's a very convenient way of doing system development of advanced antennas, signal processing. Here at the RF Systems Test Facility, we have 6 anechoic chambers that cover a broad range of frequencies. I will be describing each of the chambers. There are a number of mechanically rotating antennas that could be replaced in the future with phased array technology for electronic beam steering. Starting with the large near-field scanner, here at Lincoln Laboratory, we've been developing low-cost phased array antenna technology. And recently, a large S-band phased array was tested here in our large near-field scanner facility, where we were able to calibrate and measure the far-field radiation patterns of this multifunction phased array radar system, MPAR, which is going to be used to do weather surveillance and aircraft detection. Here in the large near-field scanner chamber, we have the Airborne radar test bed. We have an operator station, signal processing equipment, RF front ends, and then a large phased array antenna, which we would typically measure the amplitude and phase of each of the antenna radiating elements that are connected to transmit-receive modules. We calibrate the phase and amplitude so we can accurately steer a beam. Moving on to the compact range facility, we have a large reflector antenna that's used to simulate a plane wave from either a radar signal or a communication signal many miles away. We have a very large quiet zone, about 12 feet in size. We can do radar cross-section measurements. We can do antenna measurements of large apertures. We can handle test articles that weigh up to 2,000 pounds. We have a gantry crane that can be used to ride into the chamber with the personnel and equipment. The compact range system has this large 24-foot diameter reflector antenna with 7 feeds to cover UHF through roughly 100 gigahertz. And the whole antenna structure weighs 44,000 pounds. It's a very accurate surface, temperature-controlled room. For radar cross-section measurements, we do background subtraction to get accurate low cross-section measurements, time gating, as well as other signal processing. I'm moving now on to our system test chamber. In this chamber, we can open up the double doors and drive a vehicle into the chamber to do full system integration. Sometimes we have to do electromagnetic interference or electromagnetic compatibility measurements. We can actually turn on the vehicle, and using pipe penetrations in one of the walls, we can pump out the exhaust gases and run a full system checkout on a ground vehicle. We also have an overhead crane system. If we want to test an unmanned air vehicle, we can suspend it from the overhead crane. In this chamber, we do all different types of system structures, satellites, ground vehicles, unmanned air vehicles. We have 3 other chambers. We have smaller chambers, a low-frequency tapered chamber, which can go down to UHF and up to KU band, 18 gigahertz. We have a millimeter wave chamber to test small feed horns and small reflector antennas up to 100 gigahertz. And then we also have a small near-field scanner, which can be operated up to 26 gigahertz for small phased array panels and small reflector antennas. We have a rapid prototyping machine shop in the facility where we build most of the antennas right here very quickly. We prioritize our programs on a daily basis to make sure we're addressing the most critical needs. Moving on now to our display of antennas, we have developed numerous antennas that are shown here on the wall, which have been typically installed on some of the aircraft on the other side of the hangar. All different types of ultra-wideband antennas, synthetic aperture radar antennas. Some of the antennas have been used for foliage penetration radar applications. Some of them have been used for detecting targets on the ground. For further information about the MIT Lincoln Laboratory RF Systems Test Facility, please refer to the website.